Okay, so the SIG test topic, the new SIG test topic is on convergence test. So I'm going to show you a whole variety of problems so that you can see how to kind of approach it. One thing you know for sure is going to happen is you always are going to have to do a ratio test, and that's the one I need to see all the steps. But here's a nice set of examples of just some typical ones you can look at. So the first one we can look at is, remember, we have like alternating series. So the alternating series test, if you see it's alternating, and we know it's alternating because of this term right here. So I can tell it's alternating. Then all I've got to do is show the terms that are not alternating are going to 0. So I kind of like to write it as this. The limit is sine of 1 over n. Well, as n goes to infinity, 1 over n goes to 0. That's going to go to sine of 0. Sine of 0 equals 0. Terms are going to 0. Therefore, it converges. That's the alternating series test. The next one, you should be able to recognize that's like a form of a p-series. You don't have to worry about the 100 on the top. That doesn't matter. But I would like you to see, at least rewrite it maybe so that you can see the idea that p is equal to 1.5. So it converges by p-series. P is greater than 1. Basically, we say p equals 1.5, converges. Now, the last one, I think it's okay if you really wanted to go over and say, well, this should behave like 1 over n squared. I know 1 over n squared converges. So this will converge basically by doing a comparison. Now, if you had to go through and do a proof, now I'm okay with you if you did that on the SIG test. You know, basically I'm going to compare it against the sum of 1 over n squared. If you really want to be strict with limit comparison, that's what I would use. Using limit comparison test is what you basically need to do. You take the original series, you look at the terms that sequence, it's 20 over n squared plus 5, divide it by the one you know converges or diverges. 1 over n squared I know converges. That's because of p-series. Well, if I multiply top and bottom by n squared, I get 20n squared over n squared plus 5. As n goes to infinity, that equals 20. The limit exists, and it does not equal 0. Therefore, I know that both, if the limit exists and does not equal 0, both those two series are going to converge because 1 over n squared. They both basically behave the same way. So you don't have to maybe go through all those details if you had to do a comparison or limit comparison test. Most likely you're going to probably see alternating series, p-series. Don't do too often integral tests. I want you guys to be familiar with it. But mostly it's those two that you probably are going to typically see because those are the ones that actually come up more often than the other ones. The comparison test, probably not going to see it where you need to use it. Alternating series, definitely. You definitely see that. P-series, definitely. Those ones are big, but those are usually the easy ones. So that's what you want to concentrate on, are primarily this guy and this guy outside the ratio test. Because ratio test you know you're going to have to do. So here's a ratio test example. I normally use ratio tests because I see things raised to the end and there's other stuff going on. So that tells me to use the ratio test. And this is kind of the typical one you can kind of look across. So to do the ratio test, remember you look at the n plus first case and you're dividing by the original case. But instead of dividing, I'm just going to flip over the fraction and then just do the multiplication instead. So now what I want to look at is first I'm going to look at things raised to the end. The other terms, these terms right here, the n squared and the n plus 1 stuff, when we're using those things, we're just going to move those off to the side. I want to deal with the 2 to the n and the 3 to the n. Well, I've got 2 to the n plus 1 and 2 to the n. These guys cancel. That will become a 2. 3 to the n, 3 to the n plus 1. Those guys cancel. I'm left with a 3 on the bottom. So if I just move all that other stuff together, all the other terms, and if you look at it, I can even look at dominant terms right now. Dominant term on the top is n squared times n times 2. It's 2n cubed over n times n squared times 3. 3n cubed. 2n cubed over 3n cubed goes 2/3. But all I really want to do is look at these guys right here, and if I see that both n raised to the power, they're both n cubed, well, they're both going to, this whole series right here is just going to go to 1. So I go 1 times 2/3 equals 2/3. That's less than 1. Converges by the ratio test. Okay, so that's a pretty good example of what you can use for your SIG test for when we go to do this one.